This video is on shapes of molecules. You might want to set up the little chart table I have right here for your notes because it'll keep it a little more organized. So there are 5 different shapes that I'm going to go through. So we'll write the name, we'll draw a picture, and then we'll discuss the bond angles, number of bonds, and number of lone pairs. So the first shape to discuss is linear. And I hope that word makes you think of a line because linear are molecules that are in a line. So you're going to see something like you have some element, and I'm just going to use the letters A and X for any elements. So they're going to be bonded all in a line with each other. Now it could be written like that, and now it could also be written like this with the dots for the electrons. So just know as I go through and do these examples, as I draw lines, you could be drawing 2 dots for those single bonds. So the bond angles for this are 180 degrees, because what I want you to think about is around that central atom, which is the X in this case, right? Here's my central atom. The angle is from one A to another. And you should know that that's half of the circle, which is 180 degrees. So the number of bonds are the number of shared pairs. So these are bonds or shared pairs between 2 electrons. So this one has 2. Here's one is right here and another is right here. So 2 bonds. And there are no lone pairs. There are no electrons around that central atom, so the X in this case, that are not bonded to any other, that there are no other electrons that aren't bonded, no other electron pairs. Okay, so our next shape we're going to talk about is, hold on, I'm going to draw a line here. Okay, so our next shape is trigonal planar. So tri, you should know, means 3. And planar means that it's flat. It's all in the same plane. So this will look something like this if I have X in the middle again. And I'm going to have A in 3 different sides. And they're going to be equally spaced. Like this. So our bond angles, if you can see, this would be flat. And our bond angles are going to be from A to another A. So that is 1/3 of a circle, which is 120 degrees. So the number of bonds are 3. You can see it has 1 each of the A's there. And there are no lone pairs. There are no electrons around the X that aren't bonded to other elements. So that is also 0. Okay, so the next one is tetrahedral. And you might have heard this term tetra, this prefix tetra, because it means 4. Maybe you learned about this in geometry. Tetrahedral is a shape with 4 sides. So this looks like is you're going to have, I'm going to have X in the middle again, and I'm going to have 4 sides, 4 bonds coming off of this, each attached to 4 different atoms. So this first picture is what it would look like in 2 dimensions, in 2D, like on paper. But you'll see when we build these in class in 3 dimensions, what they actually look like, and I apologize for my drawing if it's hard to tell, is one's going to be coming up, and these other 3 are coming down on the bottom. This one in the back, I'm trying to make it little, so it looks more like this. So the bond angles, we can't just do 1/4 of a circle because now we're talking a sphere with 3 dimensions. So our bond angles, so from one A to another A, so I want to make that red, is 109.5 degrees. And this has 4 bonds, 4 shared pairs, and 0 unshared pairs. Okay, so our next shape is trigonal again, which again means 3, but now it's pyramidal, which is, I hope, what it sounds like, a pyramid. So here we have that X. But now instead of the 3 being equally spaced, like up here in trigonal planar, they're kind of like the bottom of the tetrahedral, where they look like this in 2 dimensions. So here's my 2D drawing. But my 3D drawing would have, oops, would look more like this. So my bond angles, if I go back up to here, would be like from 1A to another around that central atom. And this is going to be 107 degrees. Now this has 3 shared pairs. So if you notice, we've been seeing a pattern. We've got 2 bonds, 3 bonds, 4 bonds, and now we're decreasing back to 3. But what is increasing is our unshared pairs. The first were all zeros, and this one has 1 unshared pair, and that's this right here. So that's that pair of electrons that's not bonding with anything. And it does affect the shape, because you can see when you have 3 bonds but no unshared pairs, we've got this trigonal planar flat molecule. But with that 1 there, we've got the, there we go, we've got the trigonal pyramidal. All right, so our last shape is what we call bent. And this is exactly what it sounds like. This is going to be a molecule that is not linear, but has a bend in it. So it will look like this with some unshared pairs. So our bond angle is from A to A here, which in this case is 104.5. And our bonds are 2. We've got the A to X right here and the A to X here. And we also have 2 lone pairs. So the difference between this and linear, even though they both have 2 bonds, is this has 2 lone pairs, which affects the shape. So we'll draw these in class and we'll see kind of what they look like in 3 dimensions. But there's one last thing I need you to add to your notes. And that is what we call Vesper Theory. Oops. Sorry about that. All right, let's try this again. All right, so Vesper Theory. So this is an acronym, VSEPR. You can see they're all caps like that. And it stands for valence, shell, electron, pair, repulsion. So what this means is that the electrons are going to repel each other and be as far apart as possible. So all electron pairs will repel each other because they're all negative to spread out as far apart as possible. So that's where all these shapes come about. They're all spreading apart as far apart as possible. And that's why their bond angles are all equal, because that is them being equally spaced. So we're going to come back to this theory a bunch of times as we continue talking throughout this unit. But these are the 5 main shapes, and we will talk about more later on.